Hey everybody, in this video we're going to learn how to apply perpendicular bisectors and angle bisector properties to find unknown values in the diagram. So the perpendicular bisector theorem, if you have a point on a segment's perpendicular bisector, then that point, it can be here, 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 here. Doesn't matter if you have a point on the perpendicular bisector, then that point is going to be the same distance from the segment's endpoints. So PA, that distance will be the same as PB. So we can say that the distance from P to A is congruent to the distance from P to E. P to B, excuse me, that should say PB. Now applying what we just went over, it says what is the length of IB? Now we need to know that this side, IS, is perpendicular to EB. So I already drew in a right angle that I was missing originally. So then, if you notice that B is on the perpendicular bisector of IS, which makes BI and BS congruent to one another. Okay? So then, if we know that IB is congruent to BS, we can say 2A plus 7 is equal to 2 times the quantity 2A minus 3. So then we solve for A. Okay, so we're finding the value of A. We're going to subtract 2A from both sides. 7 equals 2A minus 6. Add 6 to both sides. 13 is equal to 2A. You should get A is the value or equal to the value of 6.5. So now we have to find the length of IB. IB is one of the distances from the endpoint to the point on the perpendicular bisector. So we substitute in our value of A into the expression. So we get 13 plus 7, and IB is the length of 20. Now the converse of that theorem is that if you have a point, okay, that is the same distance to the endpoints of the segment that it's intersecting with, then this point is actually on the segment's perpendicular bisector. So because PA is congruent to PB, we can conclude that PM, or line M, is perpendicular to AB and is also bisecting AB. So then A to this point right here is congruent to this point to B. Alright, example 2. Acrobat Andy is secured by two 7-meter ropes which are attached to the ends of a 4-meter bar. What is his vertical distance from the bar to the nearest tenth? So then here's the bar, and it looks like Andy is secured by 2-meter ropes. I think these two lines are the ropes, so let's mark our diagram as such. Okay, so now those ropes are attached to the ends of a 4-meter bar. So then our top bar is 4 meters long. What is its vertical distance, or what is his vertical distance from the bar? So then, if we are trying to measure the distance of Andy to the actual point of intersection or whatever it is, that segment has to be perpendicular to that bar. That's important information. So how do you find the length of him to the bar? Well, if we notice that he is actually the same distance from the endpoints of each part of the bar. So therefore, we know that Andy we're trying to find the distance from Andy to the bar. If we were to draw an imaginary line to that bar, that imaginary line would be the perpendicular bisector of that bar. So therefore, 4 is actually divided up into 2 equal parts. So if we're trying to find the distance of Andy to the bar, if we look at it, now we have 2 right triangles. So we have to figure out, using the Pythagorean Theorem, how to find that missing third side. So we use a squared plus b squared equals c squared, where c is always going to be the hypotenuse across from the right angle. So we're going to substitute 7 into c. So it's 7 squared. And then you can pick A or B to represent either leg. So since we know only one of the legs of the right triangle, substitute 2 in for A or B. So we're going to use A. So 2 squared plus B squared equals 7 squared. So B represents the actual height of, or the distance from Andy to the bar. So if we simplify the equation, 4 plus B squared equals 49, subtract 4 from both sides, B squared is equal to 45. So now we got to figure out what B is, so we're going to take the square root of both sides. B is actually equal to 6.7 meters. So we applied the property that we learned, the perpendicular bisector theorem, to figure out how far acrobat Andy is from that bar. And we also incorporated the Pythagorean theorem. So we brought back some information from the past that is definitely necessary for you to figure out what we're trying to find.